Now, yeah, in the previous class, we were discussing on alkenes, isn't it? We have seen how alkenes are, how do they react, what kind of reactions do they normally undergo. We have seen that alkenes are otherwise called olefins, isn't it? And the reason also we have seen, and we have seen that they exist in different isomeric forms. We also have seen the sources of alkenes, isn't it? And we have seen different chemical reactions that alkenes undergo. It's an unsaturated hydrocarbon, so it undergoes substitution reaction, isn't it? These are the things that we have seen regarding alkenes. The first member, we learned in detail about the first member, and that is ethene. Only the laboratory preparation methods we have exempted. The remaining topics and all we have seen, and I hope that you all have marked the topics that we have to learn. Okay, now we also have started discussing on alkynes. Okay, and regarding alkynes, what did I tell you, children? The major source of alkynes are natural gas and petroleum. And also, I told you alkynes, they have carbon-carbon triple bond existing between the carbon atom, isn't it? Carbon-carbon triple bond is existing, and this triple bond is otherwise called acetylenic bond. What is it called, children? Acetylenic bond. Acetylenic bond. Okay, carbon-carbon triple bond is otherwise called acetylenic bond. Acetylenic bond. Okay, so I have already told you that the first member among alkynes is ethyne, otherwise called acetylene. Isn't it? Now, I also told you to learn the common names of the remaining members, remaining few more members of alkyne. The homologous series with the general formula CnH2n minus 2. Okay, don't forget the term. It is having an acetylenic bond. Acetylenic bond means carbon-carbon triple bond existing between the carbon atoms. Okay, and also I think we have discussed on the various isomers that compounds of alkynes may show. Okay, we have seen that butene, as it is an alkyne, butene shows position isomerism, but1-ine and but2-ine. And also in the case of pentyne, we have seen that it shows both position isomerism as well as chain isomerism. And those three forms of isomers of pentyne also we have seen in the previous class. Okay, now I told you it is also obtained by cracking of alkanes. Higher alkanes, once when they undergo decomposition, we also get alkyne. Okay, so these are the different sources and major points regarding alkynes. I think also I mentioned about the shape of the first member of alkyne, that is ethyne or acetylene. That is, it shows a linear shape. Linear shape. The shape is linear because this is a molecule of ethyne. Okay, linear shape. But what about its structure? In its structure, it has carbon-carbon triple bond. Okay, so these are the various points that we have seen. Now, I told you that we don't have to learn about the preparation, laboratory preparation of alkynes are not included in your syllabus. Let us move on to the physical properties. I think that also we have just gone through, but let's see that once again. Physical properties of ethyne. It has got a sweet odor when it is pure, but once when it is prepared from calcium carbide, it will be having an ether-like odor. Okay, that is due to the presence of some impurities. As we are not learning about the laboratory preparation technique, actually these all are included in the laboratory preparation methods. Okay, so due to the presence of some impurities, the one which we prepare in the laboratory will be having a garlic-like odor. Now, its solubility, it is negligibly soluble in water but highly soluble in organic solvents like alcohol, acetone, etc. It's lighter than air. It's lighter than air. Those points you can mark in all the three hydrocarbons, whether it is lighter or heavier than air. Now, about its liquefaction and the boiling point, those values are not to be learned by heart. Okay. Now, moving on to the chemical properties. This is what we were about to discuss in the previous class, but because of the lack of time, we couldn't. So let us move on to the first point, that is oxidation of ethyne or combustion. Combustion, I told you combustion reactions of all these hydrocarbons are to be learned. Okay, see, as I've told you, children, whenever a hydrocarbon is made to undergo combustion reaction, it gives you two products, carbon dioxide and water vapor. There is no doubt. Let's go through that. it contains a greater proportion of carbon than alkanes and alkenes. So all the carbon particles do not get oxidized completely, and thereby it burns with a sooty flame. We have seen that alkanes, they do have only less carbon content. They completely undergo combustion, giving you non-sooty bluish flame, isn't it? But here the carbon content is more, and because of that it will be burning with a sooty flame. It's an important point. And why is it giving a sooty flame? Because it does not undergo complete combustion. Does not undergo complete combustion, or completely is not getting oxidized. Okay, now ethyne burns in excess air with a brilliant white flame to produce carbon dioxide and water vapor and a large amount of heat. Please go through the reaction which is given there. Ethyne, when it is burnt in the presence of oxygen, it gives you carbon dioxide and water vapor. See, simply in all these reactions you can see the products are carbon dioxide and water vapor. But simply if you write these products and the reactions correctly, it's of no use. You have to learn the balanced equation itself. Okay, so in all the three, in the case of all the three hydrocarbons, you should learn. In the case of alkanes, you have to learn the combustion of both methane and ethane. Okay, in the case of alkenes, ethene, combustion of ethene, and alkyne, combustion of ethyne. All these are to be learned. Products are same in all the cases, but the only difference is the balancing. Now let's move on to the next type of chemical reaction that alkynes undergo. We know that addition reactions are the common type of reactions that alkynes or any unsaturated hydrocarbons may undergo, isn't it? What kind of reaction? Addition reaction. So we have already seen addition reactions in the case of ethene, isn't it? In the case of alkenes, we have seen the same kind of reactions will be carried out in the case of alkynes too. Okay, so let us see. Alkynes are unsaturated hydrocarbons, so they are associated with addition reactions. The triple bond breaks very easily. Why do they break so easily, children? The reason is that they are not so happy to form these kind of extra bonds between the carbon atoms. It is due to the unavailability of extra hydrogen atoms or any other atoms. They were compelled to form these extra bonds. So they'll break the bond in case of any situation. I mean, if they are provided with favorable conditions, they will be ready to break their bonds. Okay, so the first reaction is addition of hydrogen. We have seen what is that reaction called? Addition of hydrogen to an unsaturated hydrocarbon is called hydrogenation. What do you call it, children? Hydrogenation. It's called hydrogenation. So in the case of C2H2, an alkyne, is better to draw the structure so it will be more easy for you to understand. Okay, so this molecule of hydrogen is added. Again, the conditions are the same. If it is nickel, 200 degrees Celsius, I think it's not mentioned in your textbook, but nickel, 200 degrees Celsius, and it is also called catalytic hydrogenation. Okay, now what happens? Hydrogen atoms will be getting added onto these carbon atoms by the breakage of one bond. Okay, one bond will be broken and these hydrogen atoms will be getting added to ethyne. Let us see how is it. In the first step, this is what happens. Okay, two hydrogen atoms got added up. Now, it's still unsaturated because there is exists a double bond between the carbon atoms, and this is now ethene, isn't it? Now continue the hydrogenation process. What happens? You're going to add hydrogen to this molecule again. Under the same conditions, what do you get? This reaction is something that we have already seen in the previous class. Again, the second bond will be broken and the compound becomes saturated. Okay, it becomes saturated. So in the case of alkynes, the hydrogenation process will be carried out in two different steps. First, it will be getting converted into an alkene. Further hydrogenation gets it converted into an alkane or a saturated hydrocarbon. I hope you can see those reactions there. Okay, just go through those reactions. And maybe the questions will be, how can ethyne be converted into ethane? Okay, write an equation or show the different reactions to show the conversion. Write different reactions to show the conversion of ethyne to ethane. Okay, so this continuous hydrogenation reaction should be shown there. Okay, so this is how the questions will be asked. Now, what about addition of halogen? Addition of halogen. Addition of halogen is called halogenation. We have seen in the previous class, in the case of alkenes, we have seen the same, isn't it? Addition of halogen. Halogens include fluorine, chlorine, bromine, or iodine. Normally, in the case of fluorine, addition reaction of fluorine are always explosive, so we always avoid those reactions. Instead, we'll see the reactions of chlorine, bromine, and also iodine. Okay, so alkynes reacting with halogens. That's what we are going to see. The reaction is called halogenation. 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 You call it as halogenation. Addition of halogen is called halogenation. So let us see the reaction. Please do underline the sentence because there is a point mentioned there, very important point. Addition of halogen. Ethyne in an inert solvent like carbon tetrachloride. Here they have mentioned that carbon tetrachloride is an inert solvent. Okay, so here you have to mention that ethyne in carbon tetrachloride reacts with chlorine, okay, to change into ethene derivative with carbon-carbon double bond, and then to an ethane derivative with carbon-carbon single bond. So the point that you have to underline is that ethyne in carbon tetrachloride reacts with chlorine. Okay, now let us see how the reaction is carried out. The reaction is similar to that of the reaction that we have seen in the case of hydrogenation. So how will the reaction be? The first bond will be broken. Instead of that, chlorine atoms will take the position. So what is this? 1, 2 dichloroethene, isn't it? It's 1, 2 dichloroethene. To this molecule, again, if chlorine is added, continue adding chlorine. So what happens, children? Again, this double bond will be broken. Instead of that, chlorine atoms will take the position. Okay, so now what is this? What is the name of this compound? 1, 1, 2, 2, because on the first carbon you have 2 chlorine atoms. On the second carbon also you have 2 chlorine atoms. So it is 1, 1, 2, 2 tetrachloroethane. Okay, hope you got the name. So you have to learn the IUPAC name also. The only thing that happened is that the bonds are getting broken. Instead, chlorine atoms take the place. Okay, it's a simple addition reaction. Now, let's underline the next sentence also. Acetylene reacts vigorously with chlorine gas in the presence of sunlight to give out flames. Please do underline that sentence. It's an extra or an exceptional reaction. Acetylene can also react with chlorine. This is not the only way by which acetylene reacts with chlorine. Here, what is happening? Ethyne is taken in an inert solvent and chlorine gas is passed through it. But acetylene can also react with chlorine. How? Very vigorously in the presence of sunlight. In the presence of sunlight, the condition is getting changed. The reactants are the same. Acetylene or ethyne reacting with chlorine. Reactants are the same. Have you followed? When ethyne and carbon tetrachloride, see the products that you get. Stepwise halogenation is getting carried out. Okay, but if acetylene is reacting with chlorine in the presence of sunlight, the reaction is very vigorous. It's very vigorous, and as a result, what happens? See the products that you get? You're getting carbon and hydrogen chloride. Okay, it's a very important reaction because the reactants, as they are the same, you may get confused there. So don't get confused. So this is acetylene reacting with chlorine. Acetylene reacting with chlorine. Okay, here the reaction is very vigorous. The reaction is carried out in the presence of sunlight. Followed. So here the products that you get are carbon and hydrogen chloride. Followed. Carbon and hydrogen chloride. And never forget to leave the equation balanced. It should be a balanced equation that you write. Followed. So this equation can be kept in a box because you have to learn it separately. Now let us see the reaction of acetylene with bromine. When bromine in carbon tetrachloride, just see the difference, children. Bromine when treated with alkenes or alkynes. Bromine in carbon tetrachloride is what we choose. Have we followed? So these conditions, if you note, there is nothing else to worry. These are the important things that they may highlight. Okay, so bromine, whenever treated with alkenes or alkynes, bromine is added to these unsaturated hydrocarbons in such a way that it is placed in an inert solvent like carbon tetrachloride. So bromine in carbon tetrachloride is treated with ethyne, and what will be its color? We have seen its color. It is reddish brown in color. And what happens when it is added to an alkyne? As we have seen in the case of alkene, the same thing happens. After a few seconds, the brown color disappears. Reddish brown color disappears. The fading of this reddish brown color will be quick in the case of alkenes, because immediately they are getting converted into saturated ones, isn't it? But it takes a few extra seconds to get converted into a faded color in the case of alkynes, because two different steps it has to undergo, isn't it? First, it gets converted into alkene, then to alkane, isn't it? So in that case, it takes a bit more time to get its color faded. So let us see those reactions. What is the reaction? Bromine, when treated with acetylene or ethyne, what is the condition? Bromine in carbon tetrachloride. What is its color? Reddish brown in color. Now, first what happens? Bromine will be getting added to this acetylene, giving rise to 1,2 dibromoethene, isn't it? Now you continue adding bromine in carbon tetrachloride to this compound. So what do you get? You're getting 2,2 tetrabromoethane. Exactly as we have seen in the case of chlorine. Have you followed? So here, the points that you have to note, you will write the equations correctly, but you may miss the conditions. Never miss it out. Because in organic chemistry, conditions are very, very important. Doesn't mean that in organic chemistry, conditions are not important. No. So you can see that the reactions will be same in most of these reactions, but according to change in conditions, products will differ. Okay, so bromine in carbon tetrachloride is added to ethyne. Its brown color disappears due to the formation of addition products. It's very similar to that of chlorine. The reaction is already shown there. Please go through it. Now, reaction with iodine. Iodine reacts slowly with ethyne in the presence of alcohol. Please do keep it in a box. Iodine reacts with ethyne in the presence of alcohol to form a diiodo derivative. So the reaction is again carried out, and further reaction is not carried out. Okay, the reaction is very, very slow. It's already mentioned there. So the first step itself is slow, so we are not going for the next step. Okay, so it just stops its reaction after the formation of an alkene. Okay, the reaction is carried out in the presence of alcohol. Please note it. Now, addition with hydrogen chloride. Addition with hydrogen chloride, which is also very, very simple. You have already seen the reaction. In the case of alkenes, you have seen this type of reaction. When hydrogen chloride, we are actually learning organic chemistry is very simple. See, there are two parts for this reactant, isn't it? One part will be joining onto the first carbon. Second part will join to the second carbon. So let us see how is it. And for that, one bond is to be broken, isn't it? So you get the first product. It is an addition product that you get. Again, if you continue adding HCl. What happens, children? The next bond will also be broken. Okay. So C, single bond, C. These are already there. Now, next hydrogen and next chlorine. Have you followed? So this is how the reaction will be carried out. So you get CH3, CH, Cl2. CH3, CH, Cl2, 1,1 dichloroethane. 1,1 dichloroethane. Followed. You started with ethyne. Okay, and first you got 1 chloro, or you can simply write it as, or mention the position, 1 chloroethene. Then again, if you continue adding HCl, you're getting 1, 1 dichloroethane. Okay, there is nothing to keep in your mind, or there is nothing else to learn by heart, nothing. Please never learn anything by heart, especially in chemistry. Okay, understand and learn, very simple. Now, under the uses, just underline, actually uses are not mentioned for you according to the syllabus. The latest syllabus says that the uses are not required, but still underline the third point, because they may ask you based on that. For artificial ripening and preservation of fruits, have you seen the third point? Please underline that. It's the ethyne or acetylene. It's used for artificial ripening, and it is also used in preservation of fruits. Please do underline that sentence. Okay, now moving on to the chemical test to distinguish alkanes, alkenes and alkynes. The only one test. There are 3 or 4 tests given there. Actually, children used to learn all these tests. It was there in the syllabus. For you people, we learn only one. That is bromine and carbon tetrachloride. That is the reactant, or that is the chemical reagent that we are going to use to distinguish between alkanes, alkenes and alkynes. But we cannot say that it can be used to distinguish all the 3. Instead, you can mainly say that bromine and carbon tetrachloride can be used to distinguish a saturated hydrocarbon from an unsaturated hydrocarbon. Have you followed? Because bromine and carbon tetrachloride will not show any coloration, or will not show any change in its color when treated with a saturated hydrocarbon like an alkane, because it's not forming any kind of addition products there. Followed? But in the case of unsaturated hydrocarbons like alkenes and alkynes, we have seen bromine and carbon tetrachloride, which is reddish brown in color, will be getting faded. Its color fades due to the formation of a saturated hydrocarbon, or due to the formation of a saturated compound. Have you followed? So I hope it is clear. Let's move on to the first point. On adding a few drops of bromine solution in carbon tetrachloride to the hydrocarbon, alkanes, which are saturated hydrocarbons, no change is observed. But for alkenes, reddish brown color of the solution gets decolorized. Alkynes also show the decolorization of this reddish brown color. But in case if they are asking you how to distinguish using the same chemical reagent, how to distinguish alkenes and alkynes, actually both shows the same observation, means the reddish brown color fades. But in case if they are asking how to distinguish, you can say that in the case of alkene, reddish brown color of bromine in carbon tetrachloride fades quickly. But in the case of alkynes, this fading of color, reddish brown color, takes place slowly. Have you followed? Because it has to undergo 2 different steps in order to get converted into a saturated compound. Okay, so decolorization takes place very quickly in the case of alkenes, but a bit slowly in the case of alkyne. Followed? No other tests are meant for you to learn. So here we come to an end of this chapter, organic chemistry. Alcohols and carboxylic acids are not included in your syllabus. Have you followed? So you don't have to worry about that. Now, we have already seen exercise 12A. Isn't it, children? Hope you have just cross-checked all your answers. I told you to find the answers yourself. I've already sent the answers of those exercise questions. I hope you have corrected. If there were any mistakes in your answers, I hope you have done the correction. Okay, now we'll move on to exercise 12B. All the questions are not to be discussed because we know some of the topics are not included. So let us go through the main questions. I mean the questions which are supposed to learn. And see, many questions will be direct ones, so we won't discuss all those. We'll just read the questions and I'll tell you. Question number 1, state the sources of alkanes. Sources of alkanes. Alkanes are mainly obtained from natural gas and also from petroleum. Most of the hydrocarbons are obtained from natural gas and petroleum. Now, and it's also given there as a in the beginning part. It's already given there, so please go through all those points. Methane is a greenhouse gas. Comment. It's a very, very important question. Okay, so in page number 198, you can see a box. Okay, the first paragraph of that box is the answer for this question. Give the general formula of alkanes. You know the general formula. Draw the structures of isomers of butane and pentane. You know it. You know how to draw the structure of butane and pentane isomers. We have already discussed. Okay, in the case of butane, you have isobutane, isn't it? Normal butane and isobutane. In the case of pentane, we have normal pentane, isopentane, and neopentane. But once when you write their structures, please don't forget, you should not use the condensed formula. You have to write the complete expanded structure itself because they have told to draw the structural formula. Okay, don't forget to write the molecular formula. C5H12, never forget it. Okay, because only then they'll be able to understand that these compounds shows same molecular formula. Again, never forget to write their IUPAC names. So these 3 points are to be mentioned in your answer once when the isomers are asked. What are the 3 different points? The first thing to write the molecular formula. Second thing to write the expanded structure. The third thing to write their IUPAC name. You can also mention the common names in bracket like neopentane, isopentane, etc. Okay. Now, fifth question, write the molecular formula, electron dot formula, and structural formula of methane and ethane. I hope you can draw it. See, I'm moving through all these questions, believing that you have the idea of all these. If you have any doubts on any of the questions as I move on, please ask me. So we'll discuss on that particular point. Now, moving on to question number 8. 6 and 7 need not to be, because we did not learn the laboratory preparations. I told you that you need not concentrate on. So moving on to question number 8. What is a substitution reaction? It's already given there as a footnote in page number. Footnote is given in page number 186. Okay, as a footnote, you have to write that definition. Give the reaction of chlorine with ethane and name the product formed. Okay, you know that. Name the products formed when methane burns in sufficient air. You get carbon dioxide and water vapor. Insufficient air, you get carbon monoxide and water vapor. Okay, don't forget. And again, if the supply is less, we have seen that it gives you carbon. Okay, so based on the conditions, you have to write the answers. Give a balanced equation. That's also asked. My dear children, please don't leave the equations unbalanced. It's a wastage of time that you do. Okay. Now, moving on to question number 10. Write the names and formula of the products formed when methane and ethane reacts with chlorine and bromine. They are undergoing what kind of reaction? What kind of reaction will alkanes undergo? Methane and ethane, they are saturated hydrocarbons, isn't it? They'll be undergoing substitution reaction. So, names and formula of the products formed. Okay, when methane and ethane reacts with chlorine and bromine, give the chemical equation. So, you have to write all the substitution steps in this question. Okay, now, question number 12. Write the equation for the complete combustion of methane and ethane. Very important question. Moving on to question number 13. How to convert methane into chloroform. It's one of the substitution reactions. Methane getting reacted with chlorine. Okay, methane reacting with chlorine, and in those reactions you can see in one of those substitutions, you can see the substituted product is chloroform. Okay, CHCl3. So that is how you will be asked to write the conversions. Now the remaining questions of that section are not there. Okay. Now moving on to alkene. Let's move on to alkene. 12C, page number 206. First question. Molecular formula, electron dot formula, and structural formula of ethene. In bracket it's mentioned ethine. Sorry, not ethine, ethylene. Ethene or ethylene. My dear children, don't get confused between those names. ethene or ethylene, ethyne or acetylene. Okay, these terms should be there with you always. Okay, molecular formula, electron dot formula and structural formula. I know that you can write it. Question number 2, molecules of alkene family are represented by a general formula. What do N and 2N signify? N signifies the number of carbon atoms and 2N signifies the number of hydrogen atoms in that hydrocarbon. What is the name of alkene when N is equal to 4? It's butene, isn't it? What is the molecular formula of alkene with N equal to 4? You know it, C4H8. Molecular formula of alkene if there are 10 hydrogen atoms in it? CnH2n, isn't it? So C5H10. What is the structural formula of the third member of the alkene family? They are asking you the structural formula. Okay, don't get confused there. Write the molecular formula first and then draw the structure. That's all. Okay, draw the structure of the third member. For that, what will you do? First, write the molecular formula. It's C3H6. And then draw the structure. Write the molecular formula of the lower and the higher homologous of an alkene which contains 4 carbon atoms. 4 carbon atoms. So, lower member is C2H4 and then for a higher member, they are asking you with 4 carbon atoms, so C4H8. Okay, molecular formula are only asked. Moving on to question 3, distinguish between saturated hydrocarbon ethane and unsaturated hydrocarbon ethene by drawing their structural formula. So they are asking you to distinguish. So what will you do, children? Whenever they are asking you these type of questions, draw the box. Never forget. Don't write in paragraphs. Okay, so please do draw the box, write alkanes, alkenes, select the first member in both cases, draw their structures and mention the differences. Okay, now draw the structures of isomers of butene and write their IUPAC names. Okay, we have already seen it. You know the IUPAC name. See, all these questions which we discuss in the class now are to be written in your notebook. I'm not telling you to write these in your notebook these days after your exam. Don't forget, children, it's not for the sake of the teacher, it's for you. Okay, so whatever questions we are discussing, I hope you are putting tick marks there. Okay, so these questions and their answers should be written in your notebook after your exams. Now, question number 6. Ethene, when reacts with halogen, form saturated products. Name them and write balanced equations. We have already seen the reactions and also their products. So once when you write their name, write their IUPAC names itself. Now, give the conditions and main product formed by hydrogenation of ethene. Conditions, don't forget conditions. Nickel in the presence at 200 degrees Celsius. If platinum or palladium, the reaction can be carried out at room temperature. The main product formed by hydrogenation of ethene. It is, what is the product that you get by hydrogenation of ethene? You get ethane. Isn't it? You get ethane. Now, moving on to question number 8. Write the following properties of ethene. Physical state. Okay, it's a colorless gas. Now, odor. It has got, I told you, it has got a faint, sweetish, or it has got a kind of sweet smell. Now, density, it's less dense than air. And about its solubility, it's not much soluble in water, mainly soluble in organic solvents. Moving on to question number 9. B and C are there included. Ethene to 1,2 dibromoethane. So what is this reaction, children? It's actually halogenation. To ethene, bromine and carbon tetrachloride is added. That's how you get 1,2 dibromoethane. Okay, so have you seen how the questions are asked? Conversion, how to convert. Now, ethene to ethane. This is hydrogenation, addition of hydrogen. Okay. Question number 10. Write balanced equations when ethene is burnt in excess of oxygen. You know the reaction. Ethene reacts with chlorine. That also is a direct question. It combines with hydrogen chloride. We also have seen this reaction. Now, a mixture of ethene and hydrogen is passed over nickel hydrogenation reaction. All these are direct questions. We have already seen it. Okay. Moving on to question number 11. Give the formula and names of A, B, C and D in the following equations. You may feel that the question is very difficult, so confusing. Nothing. It's such a simple question that they have asked here. But see the way that they have presented the question. That is all. So you have to be familiar with their way of presentation. That's all. See the first one. Methane getting converted into a product A and then into B. So what is actually happening here? What is happening? What kind of a reaction have they shown there? It is a substitution reaction. See, need not get confused. CH4, this is what they have shown, giving A. What does it mean, children? CH4, chlorine molecule is added. On adding chlorine molecule, HCl is just removed as a byproduct. A main product is obtained and that is A. What will be the main product? What will be the main product? It will be CH3Cl, chloromethane, isn't it? This will be the first product. Now again, chlorine is added minus HCl, which means this is a substitution step. Okay, chlorine is again added, so HCl is removed. So what happens? You're getting CH2Cl2. So this is A, this is B. So like that it goes on until you get CCl4 and that is G. Have you followed? That is the first case. Now, they are asking you to write the formula and also the name. Okay, so in the case of first question, 11A, you have to write the names as well as the formula, okay, of A, B, C and D separately. Now, moving on to B, what is the reaction that they have shown there? It is hydrogenation that they have shown, isn't it? Hydrogenation. C2H2, to which hydrogen is added. So what is happening? You get C2H4. Followed? And that is A. To this again, what is added? Hydrogen is added. This is A. To this again, hydrogen is added. So what do you get? C2H6. This is B. Again, what they have said, they are asking to add bromine to it. And they said that minus HBr. So from this, what do you understand, children? If it is minus HBr, it is a substitution reaction that is carried out. This is an alkane now, isn't it? It's an alkane. To an alkane, halogen is added. It's no more addition, it is substitution. So as it's a substitution, hydrogen bromide will be eliminated. And what will be the product that you get? C2H5Br. This will be the product. Now again, they are asking to add bromine. Okay, and they have said that HBr is eliminated again. So what is the next step? Instead of one hydrogen, C2H4Br2. Have you followed? So this is how to check what they have asked and then write the answers accordingly. Moving on to C. I hope it is clear to everyone. Okay. Now C2H4 plus B is giving you C2H6. The conditions are also mentioned. You're asked to identify what is B. What is B? It is hydrogen. Hydrogenation reaction. Now moving on to question number 12. Write the name and formula of the product formed in each case. Under these, I think the first one, A and D, we have already learned. A, C2H4 plus Cl2. Simply an addition reaction. Then it's an addition reaction because it's an alkene to which chlorine is added. So it is C2H4 Cl2. Nothing else. Moving on to D, CH2 double bond CH2 plus HBr. What will be the product? You get it as CH3 CH2Br. CH3 CH2Br. It's getting added. Okay. The remaining questions are not included in your syllabus for time being. Okay, see, I think after this year, next year onwards, all these accepted portions will be included. I hope so. Because all these are important. You have to learn actually all these laboratory preparation techniques. But maybe due to the present situation, they have omitted all these. So we have completed discussing all the exercise questions. One is left over still, that is exercise 12D. We have only few questions to discuss under that. In the next class, we'll complete that also. So organic chemistry as a whole will be completed. And in the next class, we'll start discussing on the important points of chapter number 1. Okay, so I hope it will be a revision also for you. So tomorrow, I think tomorrow we have a class. So tomorrow we'll finish off 12G. Okay, and then we'll find the answers. I mean, we'll discuss that. Don't forget to write the answers of all these questions in your notebook after your exam, children. Be honest. I know that you will do it. Now, tomorrow we'll have a discussion on lesson number 1. Got it? So thank you very much, children. Have a nice day. Prepare well for your exam.